For today's lesson, our focus standard comes from Grade 8, Functions, Standard B, Use Functions to Model Relationships Between Quantities. Our topic for this lesson comes from our new unit, Applying Functions, Make Predictions in 3 Views. Our essential question today is, how do each of the 3 views compare when making predictions? So please take a moment, as always, to pause the video if you need to and make sure that your standard, the topic, and essential question are copied down into your header, along with today's date. Set your Cornell notes with your questions column and your note column, and resume the video when you're ready to begin. So in this video, we're tying it back into our mathematical models lessons on the 3 views of relationships. And we're going to be looking at how each of the 3 different views can help us in making predictions, and which ones are the pros and cons of using each. So that's why I ask in our essential question to compare them. So I've come up with a story problem here about Jamal. Jamal is a teenager, and when he was born, his parents set up a college fund for him by depositing $50 into an account. Every year on his birthday, they deposited $75 into his account. So this is his college fund. So we're going to ask 3 different questions, and we're going to decide which of the different views would be best as we answer these 3 questions. And it may be good to review right now that those 3 different views are a table, a graph, and an equation. So here's our first question. When Jamal was 5 years old, how much money was in his college fund? Jamal is currently 13 and a half years old, and he wants to determine how much money would be in his account now if the $75 was deposited at a constant rate over the whole course of the year, and how much would be in his college fund at 13 and a half years old. Number 3, after Jamal turns 18 years old, how much money will be in his college fund? So we're going to do making predictions and estimations. It's going to be okay if not all of our answers are exact, but that's going to be part of our comparison of these 3 different views. So let's focus on this first question. We have all the information we need to begin in our story problem, and when Jamal was 5 years old, we want to know how much money was in his fund. Which do you think might be the best choice here? Do we want to use a table, a graph, or an equation? And for this, because it's a relatively short number of calculations, it's 5 calculations, we could use any of them, but if it's just a few data points out, like this is 5 data points, then it's pretty easy to just make a table. And so for this first one, what I'd like you to do is set up a table. And it's important to note that for all 3 views here, we're going to use X as representing Jamal's age in years, and Y is going to represent the amount of money in his college fund. So like I said, for this first question, because it's only a few data points, and our numbers are pretty easy to calculate, I want us to go ahead and just set up a table. So I'm going to pause my video here. Go ahead and feel free to do the same. And I want you to see if you can use the information from our story problem to complete this table. And then let's check back and compare our work. So how does it compare? So we were given all of our X values, his years, from 0 to 5. And we know that when he was born, they put $50 into his account. So his starting value was at 0 years, $50. And then every year they deposited $75. And so I just added 75 each time, and I kept coming up with my next number. And so this is what I would expect our chart to look like. And so it would be easy to answer this first question. When Jamal was 5 years old, how much money was in his college fund? Well, in 5 years, he's going to have $425. So like I said, just took us a few calculations. Some of us might be able to do that in our head. There's only a few data points, so a table makes sense for that. So now let's look at the second question. Jamal is currently 13.5 years old. When he wants to determine how much money would be in his account now, if the $75 was deposited at a constant rate over the whole course of the year, how much would be in his fund? So instead of it just happening on his birthday, like on his birthday, $75, if that amount was slowly deposited every day in equal increments for over the course of the year, how much would it be when he was 13.5 years old, since that's how old he is now? So we've used a table, and we could, but going out 13.5, so extending our table, and then having to come up with a decimal value, right? Our table is not really set up for that. So a better option would either be a graph or an equation, and really either one of those would be a good choice. And I think for this one, we're going to go ahead and use a graph. So I've come up with a setup here. So I'd like you to create a graph in your notes with, again, since Jamal's age is represented by X, that's going to be on our X axis, and this might be, you might want to follow the same increments that I did, the same scale. And on the Y axis, we know that's representing the amount of money. And what I would do, since I already have a table of values, or I can do a few calculations of these in my head, if I was having to go straight to the graph, I may just do a couple of these in my head and plot those few points, and then make my line, right? We know to do that from our mathematical models unit. Looking at the way we have our scale set up, it might be best to use 0 and 50, because that's our starting value. I could use 1, because it's pretty easy to find that, or I could use 2. I like this nice round 200. That's easy to plot. And then maybe 4, 350, and that might be pretty easy to plot too. So I'm going to use those 3 points, and I'm going to plot them on my graph. So pause the video here, get your graph set up, and try plotting a few points, either the first 3 or maybe 0, 2, 4, and then let's continue, resume the video, and we'll continue from there to compare. So your graph should start to look like this. We know that the starting value at 0 years, they deposited $50. If we do add 75, at 2 years, we know he has $200 in his account. And if we add 75 twice to that, and we've already done these calculations, then we know at 4 years he'll have 350. So I plotted those 3 points, and as a reminder, the question that we're trying to answer is how much will he have when he's 13.5 years? So let's see if we can figure out where that's going to be on our graph. And I'm going to mark a little line here. So here would be where 13 is, so 13.5 on my graph is this x-axis, or x value line right here. Maybe make that red. And so what I can do is now just connect these points and see how much does he have when I get to 13.5. And we should be able to recognize that this looks like a very linear model. We should see that in our table, and then definitely start to see that in our graph. I'm just going to grab an arrow. You'll want to grab a ruler and connect our points and extend it all the way through the graph, being careful to go right through the center of our points. And so, like I said, we just took a few data points. We could calculate a few of them, and then the nice thing about a graph is then we can just extend our line out to make that prediction. We don't have to do every single point along the way. Like if we did a table, we'd have to calculate every point along the way up to 13.5. And so that would be quite a bit. So here we're able to just take a few data points and then extend to make our prediction. And with the scale that I used, every tick mark on my y-axis is worth 20. And so I'm at 1,000, and then 20, 40, 60. So it looks like the prediction, according to this graph, would be about $1,060 in his account at the age of 13.5 if the $75 was deposited a little bit every day over the course of the whole year. So there's where our graph is handy, so it saves us some time from having to calculate every single value out to make a prediction. And then for our last one, after Jamal turns 18 years old, how much money will be in his college fund? And so this is again one where I wouldn't want to use our table because I'm going to have to calculate that all the way out, and I'd have 18 calculations out here. And on my graph, I could definitely use a graph, but the way I set it up, 18 isn't on my graph. And so, and if I had planned for it, I could have done that. But another way, we can always use our equation, just like we could have used our equation for any of these. So we have some nice information here. Let's see if you can find the m and the b value from either the table or the equation or even the description. It's all the information is up here to find the slope and the y-intercept. So see if you can do that, and then let's write an equation that will help us make our prediction for how much money is in his account at 18 years. So let's see if we agree. I said that the equation is y equals 75 over 1 x plus 50. Or here I've written it again where we're going to do some calculations to make our prediction about the amount of money in his account after 18 years. So the 75 over 1, that's how much it's increasing every year, right? In our table we see that, and in the description it said every year they deposit $75. So this is our x is changing by 1, and our y is increasing by 75 every time. So change in y over change in x, 75 over 1, that can simplify to 75. And our starting value, when he was 0, they deposited $50. That's our starting value, or our y-intercept, and so plus 50. So now, to come up with this answer, since we know x represents age, all we have to do is substitute 18 for x and do our calculations. So go ahead and set this up, do our calculations, and let's see if we agree. So here's what I did. As I showed you, I substituted 18 for x. I multiplied that by 75 to see how much every year, if we did the $75 every year, they would have made $1,350 in deposits. But then we need to also add in the $50 that it started with on their very first deposit, and so that takes us to $1,400. So when he's 18 years old, using our equation, we can know that, or predict, but we know for certain that he would have $1,400. So here we took a look in this video how to make predictions, and we want to start comparing and contrasting. When is it best to use a table? When is it best to use a graph? And when is it best to use the equation? And how are they similar and different, and using them as a comparison tool? So or a prediction tool. So we're going to talk about that more in class. Please make sure your notes are complete, and you may want to get a head start on your study guide questions and your summary.